Simplify each radical on the right. Drag the reduced radical to each radical expression. So our goal here when we have radicals in the denominator of a fraction is we want to eliminate the radical. And so what you do is you multiply by the radical on the denominator. You multiply that by both the numerator and denominator. So you do radical 3 over radical 3. So if you have 5 times radical 3, that's going to be radical 15. And then divided by radical 3 times radical 3, which is radical 9. And that simplifies to radical 15 divided by 3. Okay, so this one matches here. So why do we care about radicals in the denominator of a fraction? Well, this goes back to the days before calculators were invented, something called a slide rule. And maybe your parents or grandparents would know what they are. But if you wrote a fraction in proper form like this, it was much easier to figure out a decimal answer for the division problem using a slide rule than if you had written it as radical 5 divided by radical 3. So this is something that evolved in the process of mathematics over the years, and even though we have calculators today, it's still part of the process. So this next one, we have to multiply by radical 5 on the numerator and denominator. So that's going to be radical 15 over radical 25, which is radical 15 over 5. Okay, this next one, it's 1 divided by 3 minus radical 5. Now we can't just multiply by radical 5 because that won't eliminate everything here. What we need to do is multiply by what's called the conjugate of the denominator. Now the conjugate is the same thing as the original except you change the middle sign. So the conjugate, let me write this all out here. It's going to be 1 over 3 minus radical 5. That's the original problem. And then for the conjugate, it's going to be 3 plus radical 5 over 3 plus radical 5. So what you're going to do is you're going to multiply this out, and using the FOIL method, you're going to get a simplified answer without a radical in the denominator. So this is going to be, see, 1 times 3 plus radical 5, that's just 3 plus radical 5. And on the denominator, we're going to use a special pattern. Take a look at this. It's a sum and a difference. So what we do is we square the first number, which is 9, square the second number, which is radical 25, and then we keep the negative sign, so it's going to be minus radical 25. And that's the same thing as 3 plus radical 5 over 9 minus 5, which is 3 plus radical 5 over 4. All done. Now, aren't you glad you learned that special pattern for multiplying now? It makes this whole problem a lot easier. Let's take a look at the last one. It's 1 over 3 plus radical 5, and multiplied by the conjugate, it's going to be times 3 minus radical 5 this time, over 3 minus radical 5. Then I'm going to apply the special product to the denominator, but first I have to do the numerator. 1 times 3 minus radical 5 is 3 minus radical 5. And then special product, 3 squared is 9. And then it's going to be square root of 5 times square root of 5 is square root of 25 and negative. And you know what, if you wanted to just write 9 minus 5, you could do that too. I wrote the radical 25 so you could see the step, but if you can just write 5, that's okay. 3 minus radical 5 at the numerator, and 9 minus 5 for the denominator. So that's going to be equal to 3 minus radical 5 over 4. So this one matches here. Okay, so for the simpler problems, you just multiply by the radical in the denominator. But for problems like this, where the radical only applies to one term and there's more than one term, you have to multiply it by the conjugate. And then you get to use the special product pattern of sum and difference.